Welcome to the Explainer. Today we are cracking wide open Arma 3's SQF syntax, and we're going to use the Altis Mercenary company as our guide. We're doing a total beginner-friendly walkthrough of SQF, specifically by doing a step-by-step reading of the fn showstatus.sqf file. That's the script that actually builds the dynamic PMC UI report right on a player's screen. By looking at exactly what it takes to build this menu, I promise you, the entire language is going to start to click.
Look, diving into a new programming language can absolutely feel like walking into a maze, but we are going to break down this intimidating syntax into tiny, totally manageable pieces. As the Altis Mercenary company learning guide points out, SQF definitely looks a bit unusual if you're coming from Python, JavaScript, or C#, but the building blocks, they're actually quite small. Once you get a handle on these core components, reading through an entire custom missions codebase becomes basically second nature.
So here is our roadmap for today. First, we'll cover the SQF mental model. Second, local versus global variables. Third, we'll look at arrays and mission data. Fourth, parameters and code blocks. Fifth, guard clauses. And finally, execution contexts. Let's dive in.
Starting with Section 1, the SQF mental model.
Okay, before we write a single line of code, we really need to understand how a serious Arma commission is actually constructed. You're probably familiar with the Eden editor, right? Well, the editor only places the static world markers. SQF scripts, on the other hand, dynamically generate literally everything else while the mission runs. So when a player opens their laptop in-game to view the company status via fn showstatus.sqf, that entire interface is being pulled together dynamically by the engine on the fly, not just pre-placed in the editor.
Moving right along to Section 2, variables, local versus global.
For fn showstatus.sqf to show a player something like their bank balance, it obviously needs to retrieve data. And SQF makes this super easy with a naming convention that's baked right into the syntax. An underscore instantly tells you a variable is local and temporary. On the flip side, a prefix like AMC underscore identifies a mission-wide global state. So if our UI script needs the company's total treasury, it looks for the global AMC funds. But if it just needs a temporary counter to format a line of text, it uses a local variable, something like underscore cache string. Now check this out. By utilizing this private keyword, we are practicing defensive coding. Imagine you're writing a loop in fn showstatus.sqf to display the mercenary roster, and you decide to use a local variable named underscore level. Well, if you don't declare it as private first, you might accidentally overwrite a totally different underscore level variable being used by the script that opened the menu in the first place. This kind of defensive coding is absolutely your first shield against those notoriously hard-to-track Arma bugs.
All right, Section 3, arrays and mission data.
Arma relies incredibly heavily on arrays to manage complex data structures. Say our fn showstatus.sqf script needs to display the persistent motor pool. It iterates through an array to do that. By utilizing sequential commands like pushback to append an item, select to filter it, and delete at to remove an item, scripts can manipulate massive amounts of game information. Because array indexes are the absolute backbone of this data, knowing that a vehicle's name lives at index 0 and its health at index 1 is vital for our UI to render correctly.
Which brings us to Section 4, params and code blocks.
So when you actually open up fn showstatus.sqf, the very first thing you see is this defensive parameter setup. SQF allows you to specify default values and expected data types right at the start of the file. The script isn't just loosely asking for a player level, it's demanding that if it doesn't get one, it defaults to exactly 2, and it absolutely must be a number. When you're feeding data into a fragile UI system, this strict typing prevents empty data from instantly crashing your custom menu. It's brilliant. Here is where SQF gets genuinely uniquely flexible. Code blocks, enclosed in curly braces, are treated as actual values that can be passed around. You can assign an entire block of UI generation logic to a variable, and then just run it later using commands like call or spawn. This modularity is exactly what allows a massive campaign framework to stay organized and clean, rather than degrading into a bowl of unreadable multiplayer spaghetti code. Next up, Section 5, guard clauses. Because some objects exist everywhere in the game, but only one machine actually has authority over them, guard clauses are crucial. They prevent massive multiplayer headaches by ensuring code only runs where it's actually supposed to run. In Arma, the server is the ultimate campaign authority. It owns the money, the contracts, the AI roster. The client, however, owns the player's UI and personal loadout. So if a script tries to deduct money, it must happen on the server.
Because our fnShowStatus.sqf is purely a UI script drawing elements on a player's screen, we want a guard clause explicitly checking for a user interface. If a dedicated server, which doesn't even have a monitor, accidentally triggers this script, a simple exit with check at the very top kicks it out immediately. That prevents the server from wasting valuable CPU cycles trying to draw a pop-up menu for a human that literally isn't there.
Finally, Section 6, Execution Contexts. Okay, have you ever encountered this incredibly frustrating error where the script crashes and says, "Suspending not allowed in this context"? You might run into this if you try to use a sleep or wait command inside an unscheduled context, like a remote execution call. Imagine you want to display the status report, but you want to delay it by 2 seconds for a cool cinematic fade-in. So you write sleep 2, but suddenly your game throws an error. Why? Well, because the way the script was triggered simply didn't give it permission to pause the game engine.
The fix here lies entirely in how you execute the code. You use call for quick math that returns a value right now, and you use spawn for parallel loops that actually need to pause. If fnShowStatus.sqf needs to instantly calculate the player's total assets to draw a text box, you call it. The engine halts, does the math, and returns the number. But if you want to delay that UI pop-up for that 2-second cinematic fade-in, you must spawn it. That allows it to run alongside the main game on its own scheduled timeline.
The Altis Mercenary company handles this scheduling beautifully with a clever, self-correcting defensive pattern. If our UI function is called from an environment that simply isn't allowed to use a sleep command, it can catch that error and just relaunch itself as a scheduled spawn script. This is a real game changer. It means you don't have to constantly stress about how a complex timed element was triggered over the network. The function just ensures it has the right environment before it does the heavy lifting.
All right, let's wrap this up. If you take away anything from this explainer today, it should absolutely be these 3 golden rules for mastering Arma 3 scripting. First, know your locality. Server is for game state, client is for UI. Second, know your scheduling. Use spawn if you need to sleep, and call if you need it right now. And third, treat your data defensively. Use private variables, strict parameter checks, and guard clauses.
So, Arma 3 SQF really isn't this scary mystery anymore, is it? It's just a logical, distributed game scripting environment. You've seen firsthand how simple variables, arrays, and defensive checks inside fnShowStatus.sqf form the foundation of a living, breathing mission state. With these building blocks now at your fingertips, the game engine is entirely yours to command. So, what are you going to build with it?